Let's continue our topic about function. Today we're going to talk about variable expression as an input of a function. Last time we discussed different forms of a function, as in a mapping form, as a graph form, as well as set form. That was, we started with the relation, then we discussed it into function. And last time I mentioned that normally a function could be written as f of x equals to some form of an expression depending on x. Let's say something like x squared plus 2x plus 1. This is a function. And x is your input. And whatever the outcome is, the out result is the output. And I mentioned that f specifically is just a name for the function. It could be h, like this case, h of an input. The input could be a variable like x, y, z, doesn't really matter. Normally we avoid y because you use x and y axes, but still y could be a variable, doesn't matter. So you have an input and the outcome is your output. Here are some examples. I picked 2 examples so we can go through them. Given f of x is 5x plus 1. This was an example of a linear function. And h of x is 2x squared minus x plus 3. There are 2 given functions. Last, we discussed calculation of f at a specific value. For example, f of 2. Given this is the function f, if I want to find out what is f of 2, this means replace the input x with 2. I'll get 5 times 2. Every time I see x, I'll replace 2. And you calculate that. So this would be 5 times 2, 10 plus 1, 11. So if you remember, it tells you that the input given x is 2. What is the outcome? It's 11. So you have an order pair when the x coordinate is 2, y coordinate is the output 11. And so on. What if it's h of 0? You look at the function h. Input is given 0. So instead of x, every time I see x, I'll replace 0. I'll get 2 times 0 squared minus 0 plus 3. For every x as an input, we replace 0. And if you calculate, that is positive 3. So what does it mean? That means into the function h, if you replace 0, you should get 3 as the y value. So if this is the x coordinate, that must be the y coordinate. If you're drawing it as a point on the the rectangular coordinate system. What if they ask you to find out what is f of star? It doesn't really make any difference. You would have 5 times every time I see x into the function f. This is your x input. Instead of x, you replace star. 5 times star plus 1. I cannot simplify it, but I can say this is my output, whatever this is. How about if they ask you what is h of input? Input into the function h, every time I see x, I'll replace input. What do you get? You get 5 times, sorry, not 5, 2. This is 2 times input square minus input plus 3. It doesn't really matter what that input is. They give you input value, you replace it there. How about f of 3x? This is your input inside the parentheses. So if you have 3x as an input into the function f, every time I see x, I'll replace 3x. So instead of x, instead of 5x plus 1, I should replace 5 times. Instead of x, I have 3x now, plus 1. You can simplify it and say this is 15x plus 1. This is actually called the composition of 2 functions. You have a function inside another function. How about h of x plus 1? You look at the function h. Let me write h here. H of x was 2x squared minus x plus 3. Instead of x, the input now is x plus 1. What does it mean? That means every time you see x, replace x plus 1. It would be, sorry, not h anymore. It would be 2 times x plus 1 squared minus x plus 1 plus 3. If you compare, every time I see x into the function h, I've replaced it with x plus 1. Because now the input given is x plus 1. And they say replace x plus 1. What if they ask you, what is h of, let me write an example, h of z. That means instead of x, replace z as your input. You'll get 2z squared plus minus z plus 3. If they ask you what is h of Bob, for example, every time you see x replaced with Bob, so I'll replace 2 times Bob squared minus Bob plus 3. Always use parentheses. It doesn't really matter if it's Bob or not, but use parentheses just to avoid making mistakes. How about f of square root of x into the function f? If I go up into the function f, instead of x, you're given square root of x as an input. So I'll replace square root of x. I'll get 5 times square root of x plus 1. I cannot simplify it. If I could simplify, I would do that. How about they ask you what is f of negative x? Again, you replace negative x, 5 times negative x plus 1. Try to use parentheses because it's not 5 minus x, it's 5 times negative x, and it becomes negative 5x plus 1. It's very important that you multiply correctly, do not subtract. Okay, so every time they give you a variable, if they say what is f of y, instead of given f of x as 5x plus 1, if you're given this information, you just replace the variable and say 5y plus 1. It's just change a variable. You should know the function. If you're not given the function, there is no way to deal with this. Okay. It's very important to know how to substitute variables. There is a slight idea about graphing function. We're not going to get into it that much, but I'm going to just introduce the idea. How about if you're given f of x as 3x plus 1, and they ask you to graph this function? Not always possible to graph all the function, but you can estimate how the function looks like based on just picking points. For example, if they ask you what is f of 0, you can calculate and say, I replace 0 for x, what do I get is 3 times 0 plus 1. And what do I get is 1. If you calculate f of 1, what you get is 3 times 1 plus 1, which is 4. F of 2, I'm just picking different inputs. 3 times 2 plus 1 would be 7. F of negative 1, for x, I'll replace negative 1. 3 times negative 1 plus 1. Use parentheses. Negative 2. So what did I do is just, I found a bunch of points. For example, in this case, I picked 0 as an input. That means my x coordinate is 0. What did I find as output? It's the y coordinate, 1. I replaced 1 as an input. What did I find as a y coordinate? 4. If you remember, the function should have exactly one output as one y coordinate for every x value that you pick. If I pick x equal to 2, I have one y value, which is 7. If I pick x equal to negative 1, I get one y value, which is negative 2. And now that you have a bunch of points, you can draw them in the xy coordinate system. And say, okay, this is the x-axis, this is the y-axis. Let me draw these points. 0, 1, 0 for x, 1 for y. That's a point here. Let's assume this is 1. 1 and 4. Here's 1 for x. 1, 2, 3, 4. Here, 4. That's another point. If I pick, let's say, negative 1 and negative 2. Here's negative 1. Where is negative 2? That is negative 2. That's another point. If you draw 2 and 7, 2 and 7, maybe somewhere here, 7, that's another point somewhere. And if you pick more points and so on, if I pick, for example, f of 0.5, and I ask you to calculate f of 0.5, you'll get 3 times 0.5 plus 1. And what do you get is 3 times 0.5 is 1.5 plus 1, you'll get 2.5. So we'll have another point here as if this is 0.5, what do I get is I get 2.5. If I pick one more point, maybe 1.5, I'll get somewhere here. You can see that you'll get all these points. If you pick more x values, you'll get more y values. And what you will get at the end is this bunch of dots that the more points that you pick, the more accurate the graph becomes. And we can say, okay, this is probably a straight line. If I can draw a straight line better, I'll do that. It's probably a straight line. Pardon me for not being able to draw a straight line, but it's just the idea that matters. It's just a straight line that goes through all those points. What points? The points that belong to this function. All the x values possible. For example, if I pick 2 for x, I should get a y value of 4. Y value of 7, because I had a 2 and 7 on the graph. All the points on this line should satisfy this equation. For example, if you had 3 and 10, let's say 10 was here. Is that a point on the graph? How would you know is this point 3 and 10 on the graph? How would you know is given 3 for x, y given 10, does it satisfy the equation? That means if I replace 3 into the function, do I get 10 as an outcome? What do you have is 3 times 3 plus 1, it's 10. That means yes, I have 3 for x, y value is 10. If you pick a point like 2 and 9, it becomes here. And you will see that 2 and 9 does not belong to the graph. Why not? Because if I pick 2 as an input, if you look here, if I pick 2 as an input, what did I get as an output is 7. That means there is no possible way that I get 9 as an output. I should only get 7, 2 and 7. So all the points on the line, there are infinite of them. For example, square root of 2 is a possible output, but the outcome would be a decimal value, whatever that decimal number is. So all those points create this line that goes on forever. This is just because I can say that this is a linear function and the result is a line. It's not always possible. If it was 3x squared plus 1 instead of 3x plus 1, then you would have a quadratic function. We're not going to get into graphing for a moment, but I just wanted you to see the idea. Sometimes they give you, let's do this example. Sometimes instead of giving you the function, they give you a graph and say, here's the graph. Let's try maybe something like this. Pick a bunch of points here. Let me pick straight line here. And let's do this. There is, it's always possible to make up your own function. So let's say this is 4, 5 or whatever, 5, 4, 4, 2, here's 1, here's 2. Actually, this, maybe it's better if I change it to 1, 1.5, for example. This point, this height here is 1.5, and here, let's say -4 or something. Okay, and they tell you that all these points that we drew, this straight line, that straight line, they all belong to a function. That function is called the f of x. It could be h of x, whatever. And they ask you this, calculate f of 0, for example. And they ask you, find out what is the number as an output. You're not given the function. You do not have the form of f of x equals to maybe 2x plus 1. You do not have this. They're giving you the graph, and they ask you, based on the graph, tell me what is f of 0. Think about this as what it means. Normally, you're given f of x equals to something. And the something on the right side, let me write this, is an expression depending on x. This is our input. And what do you get as the output? Input is your x coordinate, output, this is your y value. So what is given at this point is the input, which is 0. That means you're given the x coordinate. What do they want is the output. They want to find out what is the y coordinate. This is the question. So find out where is the point on the graph with the x coordinate of 0. Let me choose a different color. So x0 is here on the x-axis. This is the x-axis. x0 is here. Where is the point on the graph? This is the point on the graph. Where x is 0, it should be on the graph. Either it's on the straight line or somewhere else. In this case, this is the point. What is the y coordinate at that point? It is 1.5. So I can say f of 0 must be 1.5. How about if I ask you what is f of 4, for example? You find out this is x value of 4, x value given 4. You want to find out what is the y coordinate. X given 4, what is the y coordinate? This is the corresponding point. Y coordinate is 2. So I can say must be 2. Let's put another point here. Say this is 6. Now, if I ask you what is f of 5, what would be the answer? I hope you pause this and think about it before I give you the solution. Sometimes it's good to think about it before I give you the solution. If it was in the classroom, I could stop at this point and ask you. But in the videos, I'll write the question and answer it. So it's kind of disappointing to me that you cannot answer. So think about it. What is f of 5? I find x value given 5. What is the y value? This is the question. I find x5. Here's the point with x equals to 5. But if you look above, there is another point with the x value equal to 5. So which one do I consider? Do I consider 4? Because the y value here would be 4. Or the y value 6? Or should I say both of them? At this point, I hope you remember that if you have a function, you're not allowed to have two different y values. So it is not possible to have that. That means you should never have 2 points with the same x coordinate and different y values. If you remember the vertical line test, here the vertical line goes through 2 points. That tells you this is not a function, so you cannot discuss this. That's why originally when I graphed this, there was no other point above 4. So I'm going to go backward and erase those. But I hope you understand the concept. Okay, so let's say at this point, if I ask you what is f of 5, you should be able to say, okay, at x equal to 5, what is the y value? Y value is 4. How about f of negative 4? This is negative 4. You might ask yourself, but the y value is not given. Y value here is very clear. It's on the x-axis, so the y value is basically 0. What is f of 7? I find 7. Where does the point correspond to 7? I don't see any point. So what does that tell me? That tells me this is undefined, which means 7 is not in the domain. This is what it means. That means if you pick 7, I do not have any y value to give you. There is no point correspond to the 7. If I pick f of square root of 2, square root of 2 is somewhere here. It's 1.4. Where is that point? I don't see any point on the graph for square root of 2. I do not see any point if you look at the vertical one. So what does it mean? It means again undefined. There is no point like square root of that correspond to square root of 2 for x. So square root of 2 is not in the domain either. But if I ask you what is f of negative 0.001, you might be able to answer this one. Find negative 0.001 is very close to 0, somewhere here. negative 0.0001. What is the y value? I found the point here. The y value, 1.5. I'm not sure that this is a good idea to do that, because I have to tell you, maybe this is negative 0.5. So you know negative 0.001 is there. Okay. Sometimes it's not clear. So if I ask you what is f of negative 1, you may not be able to answer it because negative 1 is here. And I do not know what that y value is, whatever that is. You can estimate and say, okay, if this is negative 1, this is probably like 1. So I can say something close to 1. Close to 1. But I cannot be sure. I can just tell you where the location is. I cannot say what is that number unless it's given. Okay, so based on the graph, you can find out the corresponding values. And here is one thing that you should know. If I ask you this one the other way, what if I do not give you the input and give you the output and say this is 4? And ask you what number goes in here? F of what equals to 4? Based on the given graph. So you look at the graph, and what is the given information? The given information is not the x. You're given the y coordinate and say y is given 4. What is x? I look at the y values. This is the y-axis. I'll find out 4. Okay, so here is the point with the y value 4. What is the x value? X value is 5. I can say, let me go up here. I can say x must be, this guy must be 5. So this input must be 5. You can go back and forth between. The only difference is if I ask you what is f of f at some point equals 1.5. Can you tell me what that point is? Here, at 1.5 given as y value, I can have 1 as an one of the points. I can have 0.9, 0.8, 0.7, 0.77, 0.66, all those numbers. So all these are possibilities. So it's not only one number that I can answer here. I can say x can be any number, maybe write it here, any number from negative 0.5 to 1. If I pick any number for x in this range, they all have y value of 1.5. So instead of showing it as writing it this way, normally you will say it's an interval. And we learned the interval notation already from negative 0.5 to 1. Because any number in between is possible to have the y value of 1.5. It doesn't contradict the fact that it's a function, because for function you only care about one output. You do not care about multiple inputs. Okay. Now that we talked about graphing, let's discuss the domain, because the domain is very important. Last time I mentioned a bit shortly. Now we're going to discuss it for two specific cases. For rational functions. If you remember, rational function were two functions, it's always contains a denominator where there is variable in the denominator. Normally they write the function in terms of px divided by qx. That means you have a fraction where there is a numerator and as well as the denominator. There could be constant, but the denominator normally depends on variable x. Otherwise, it's a linear or quadratic or a polynomial type. And if you remember, I mentioned that if you have a fraction, the only time that this fraction is undefined is when the denominator is 0. Numerator could be 0, that's not a problem, but if denominator is 0, you definitely have an undefined fraction. So if q of x, which is the denominator, if it's 0, then you have an undefined value. So if we want to find out the domain, we want to put what x values are possible to have in the domain is the one that give you a value for y as well. The ones that do not give you undefined values. All real numbers are possible except the ones that makes the denominator 0. It makes qx, which in this case is the denominator. So here qx is the denominator. If the denominator is 0, then you have an undefined value. The domain would be all the real numbers are okay except the ones that makes the denominator 0. Here's an example. Is it okay, for example, here for me to replace 0 into the function? Can I pick x value of 0 for this function f of x equal to x plus 1? If I replace 0, what happens? I get 2 times 0 plus 1 divided by 0 minus 3. What do I get is negative 1/3 if you simplify. So yeah, it is okay because if I replace 0, I got a 1y value. But now the problem starts if I replace 3. What do I get is 2 times 3 plus 1 divided by 3 minus 3. You will get 7 divided by 0, which is an undefined value. So can I have the point 3 in the domain? Not really, because I didn't get any y values. This is not possible. So 3 cannot be in the denominator. And what was the reason? Because it made the denominator 0. So if you're dealing with rational functions, you just need to figure out where this denominator is 0 and take out that point. So where do I get x minus 3 equal to 0? You solve this equation. And what is the answer? This is a linear equation, so x equals to 3. So what is the domain? Domain is all real numbers except 3. I can replace any x values that I want into this function. I will get a number. I replace 0. That was not an issue. You can replace 1. It's not going to be a problem. But the only problem starts when you replace 3. You do not get any y values. Normally, this is what you would say, but in the book, they ask you to write the interval form. So how do you write this domain in the interval form? You'll say all the real numbers are possible except this one, 3. So I take out 3. Everything else is okay. I can pick any numbers except 3. So how does it look like in interval form? If you look at the number line, it's from negative infinity to 3. 3 is not included because I cannot take that point. Union 3 to positive infinity. Again, from 3, I take out the 3 to positive infinity. Sometimes instead of union, they use comma. Okay. So this is an interval notation for the domain. Every real number is possible except 3. How about if you look at this example? Same idea. How do I find the domain? I'll figure out where the denominator is 0. I'll set the denominator equal to 0. And I hope that you remember how to factor, because it's easier to factor and solve this equation. X minus 3, x plus 2. If you multiply negative 3 and 2, negative 6, if you add them, you'll get negative 1. The coefficient of x here is negative 1. So what are the two solutions? Either x minus 3 is 0 or x plus 2 equal to 0. This one gives you x equals to 3. The other one is x equal to negative 2. So what is the domain? In all these cases, I'm asking for the domain. All real numbers except negative 2 and 3. How do I show it as an interval form? Draw the number line. Find out those 2 points. Here's negative 2. Here's 3 in order. Put them in number line in order. In order means smaller number than the next one. You cannot write 3 here and negative 2 on the right side. It doesn't make sense. What do? I take out these points. These are not possible, so I use open circle. Any number in between, it's okay. Below, it's okay. Above, totally fine. So every number is possible except these 2. How do I write it? From negative infinity to negative 2. From negative 2 to 3. From 3 to positive infinity. Negative infinity to negative 2. Union negative 2 to 3. Union 3 to positive infinity. Okay. Here, let's try one more. How about 2x plus 1 divided by x squared plus 1? Again, if you're looking for the domain, set the denominator equal to 0. Question is, find out what is the domain. What do I get is x squared equals negative 1. You can subtract 1. You can take a square root from both sides. X equals plus or minus square root of negative 1. I didn't write that step. But you can take a square root from both sides. If you take a square root, you should always consider plus or minus, the square root property. What do I get? X is plus or minus I. Here's what you should be careful. When we're discussing domain, we're only discussing real values. You're not discussing complex number. You're only discussing, okay, input as a real number. We never discussed complex number. So I cannot accept I and negative y as a solution. It's not a solution to, it's a solution to x squared plus 1 equal to 0, but it's not a real value solution. We only care about the real values. So I cannot accept that as a real solution. That means whatever number, real number that you replace in here, it does not make the denominator 0. If you replace negative 1, it's okay. Negative 1 squared plus 1 will be negative 1 squared 1 plus 1 would be 2. It's not going to give you 0. So what is the domain? All real numbers. I do not have any points to exclude. I do not exclude I and negative y because these are not real numbers to exclude. The domain is all real numbers, which means it's from negative infinity to positive infinity. Okay, I hope that makes it clear. Domain always, it's not always a point or 2 points excluded. Sometimes it's always all real number. Okay, how about the domain of radicals? We discussed rational functions. Let's discuss radicals. Radicals have one specific property. Let's focus on the square root radicals. What did we have when we discuss real values? We cannot have negative number underneath the square root, because if you have negative number, then you're creating a complex value, which is not possible if you're discussing real valued function. In this course, we only discuss real valued function. So if you have a function that involves square root, underneath the square root cannot contain a negative number. It could be something like x minus 1, that's not a problem. But if you replace x with 0, then the result becomes 0 minus 1, which is square root of negative 1. That would be an issue. So after all the simplification, you do not want the star in this case to be negative. It could be 0 or any positive number. So what do we want? We want to solve to figure out where star is greater than or equal to 0. We want to have positive or 0 underneath the square root. If you're looking for the domain, here, look at these two examples. We want to find out where is the domain of this function. Again, is it possible for me to replace 0 into this function? 0 plus 2, square root of 2. Totally fine, because now I have a point, 0 and square root of 2. Square root of 2 is a decimal number, whatever that is. I picked an x value, I got one specific y value. But is it possible to replace negative 5, for example? If I do that, what do I get is negative 5 plus 2. You'll get square root of negative 3. That is not possible now because square root of negative 3 is going to give you a complex number. We assume this is undefined in real value. In complex form, it's possible, but it's only real value function that we discuss. So this is undefined. So I say negative 5 is not in the domain. Is that the only point? Well, maybe there are more. How about negative 4? Is negative 4 okay? Negative 4 plus 2? Nope. Negative 4 is going to give you a negative number again. So negative 4 is not in the domain. Is it negative 3? And you'll see that negative 3 is not possible either. Are those the only ones? Maybe negative 6, negative 7. You'll see negative 6, negative 7. Are these the cases? Not really. You can have negative 5.2. That's not possible either. If you replace negative 6.3, that's not possible. All those decimal values in between, all the numbers specifically in a certain range, it's not possible. So how do we solve that is just to look at this idea. You want always to have positive number underneath, 0 or positive numbers underneath the square root. So we want whatever is underneath the square root, in this case x plus 2, to be greater than or equal to 0. Otherwise, we'll have a negative number. To solve this inequality, and we learned how to solve specific inequalities. X would be greater than 2. Sorry, negative 2. You can write this interval notation. Here's negative 2. Every number greater than negative 2. Because you have the equality, it should be a closed point. So what is the domain? We change the color. Interval from -2 to positive infinity. And if you look at these numbers that we excluded, they're all smaller than -2. They're all somewhere here. That's why we excluded all those sets. Okay, so the domain would be any number from -2 and so on. -2 as well. How about 3x minus 1? G of x equals to 3x minus 1. We want to find out the domain. Same idea. What you want is 3x minus 1 to be greater than or equal to 0. Solve this inequation. Solve this inequality. Then the result will give you the domain of the function. 3x greater than or equal to 1. X greater than or equal to 1/3. And draw the number line. Here is 1/3. Any number greater than or equal to 1/3. It would be 1/3 to infinity. Infinity is always parentheses. Some of you made a mistake of using brackets. It's parentheses always. Okay, how about this? You might always think that, okay, this is always the right side, all the positive number. Well, here's an example just to say there's no guessing. You have to solve an equation. Find the domain for this function. Again, you can always pause this and try it yourself. Just make sure that you understand what I'm doing, then follow the steps. What do I want? I want to find out where this underneath the square root is positive. So I want to see where 10 minus 2x is greater than or equal to 0. It is possible to have square root of 0 is 0. So it's not a problem to have 0 there. You just don't want to have negative number. Solve this equation. I'll add, subtract 10x from both sides. -2x is greater than -10. Now here, I'll divide both sides by -2. But by dividing by -2, remember you have to flip the sign. So x would be less than or equal 5. So draw the number line. Here is 5. Any number less than or equal to 5. This would be this area. So what is the result? Anything in this range. From -infinity to 5. That would be the answer. This is the domain of the function. That means if you pick a number in this range from -infinity to 5, whatever number you pick here, something like 2 for example, it's between -infinity to 5. Definitely you would have a y value. And if you calculate, sorry, in this case the function is called h, not f. If you calculate h of 2, for example, you should have a y value. There should be a result. 10 minus 2 times 2. You'll get square root of 6. It is a decimal number. But I picked 2 and I got a y value, square root of 6. But on the other side, if I pick any number outside, if I pick 6, for example, there is no answer to it because it's not in the domain. h of 6, square root of 10, minus 2 times 6. What do I get is square root of -2. Undefined real values. Sometimes we restrict the domain ourselves, but in this case that we're trying to find the domain means the points that are possible to get a y value. But in this case, if you pick 6, 7, anything, something like 5.2, you'll still get undefined values. Okay. These were a bunch of examples. I hope you try to do more examples. Think about this till we continue next time.